ಎಲ್ಲರಿಗೂ ನಮಸ್ಕಾರ. ಈ ವಿಡಿಯೋದಲ್ಲಿ ಸೊಲ್ಯೂಷನ್ ಆಫ್ ಹೋಮೋಜಿನಿಯಸ್ PDE ಬಗ್ಗೆ ಡಿಸ್ಕಸ್ ಮಾಡ್ತಾ ಇದ್ದೀವಿ. ಈ ವಿಡಿಯೋದಲ್ಲಿ ಮೆಥಡ್ ಎಕ್ಸ್ಪ್ಲೈನ್ ಮಾಡ್ತಿದ್ದೀನಿ. ನೆಕ್ಸ್ಟ್ ವಿಡಿಯೋದಲ್ಲಿ ವಿ ಶಾಲ್ ಡಿಸ್ಕಸ್ ಪ್ರಾಬ್ಲಮ್ಸ್ ಆನ್ ದ್ಯಾಟ್. Here we are going to consider equations, partial differential equations involving derivatives with respect to one independent variable. See, when we talk of a partial differential equation, the dependent variable should have at least two independent variables. But the partial differential equations which are going to consider in this part involves derivative with respect to either x or y. You don't get any derivative with respect to both x and y. ಅಂದರೆ ನಿಮಗೆ ಬರೀ ಡೋ ಸ್ಕ್ವೇರ್ ಝೆಡ್ ಬೈ ಅಥವಾ ಡೋ ಸ್ಕ್ವೇರ್ ಯು ಬೈ ಡೋ ಎಕ್ಸ್ ಸ್ಕ್ವೇರ್ ಡೋ ಯು ಬೈ ಡೋ ಎಕ್ಸ್ ಈ ಥರ ಬರ್ತಾ ಹೊರತು ಮಿಕ್ಸ್ಡ್ ಡೆರಿವೇಟಿವ್ ಆಗಲಿ ಅಥವಾ ಎರಡನೇ ವೇರಿಯೇಬಲ್ ಆಗಲಿ ಬರಲ್ಲ. ಸೊ ಇನ್ ದ್ಯಾಟ್ ಕೇಸ್ ವಿ ಕ್ಯಾನ್ ಈಸಿಲಿ ಟ್ರಾನ್ಸ್ಫಾರ್ಮ್ PDE to ordinary differential equation. So when we have partial derivatives with respect both the variables, that will be a different case. But we are considering equations such that the derivatives of the dependent variable with respect to only one independent variable is appearing in the equation. So we can easily convert that to usual differential equation. When usual differential equation is solvable, using that method we can solve homogeneous PDE also. So now first let us know about how homogeneous differential equations are solved. First we should know about this one. What is homogeneous differential equation and how to find the solution of homogeneous differential equation? As I said in the first video of partial differential equations, a differential equation is the one which involves equality and derivatives. The standard form of a differential equation of second degree, I will take, even you don't get problems of higher degree, or if you want higher degree I can write that in this form: an dn y by dx power n. I am writing differential equation, homogeneous in particular. Say here y is a function of x, only one dependent variable, one independent variable, plus an minus 1 dn minus 1 y by dx power n minus 1 plus and so on, a1 y plus a naught equal to 0. Think of this constant term won't appear. Okay, this equal to 0. Or by taking capital D equal to d by dx, I can write this in the form an d power n plus an minus 1 d power n minus 1 plus and so on, a2 into d2y. Okay, it should be dy by dx. ಇಲ್ಲಿ n minus 1 ಇದ್ದಾಗ ಇಲ್ಲಿ n minus 1 ಬರಬೇಕಲ್ವ, ಇಲ್ಲಿ 1 ಇದ್ದರೆ ಇಲ್ಲಿ 1 ಬರಬೇಕು. ಎಸ್, plus a naught into y. That is the standard form. Yes, a2 d2y plus a1 d1y plus a naught into y equal to 0. So this I can simply write in the form small f of d into y equal to 0. This is called a homogeneous differential equation. Now, to solve this homogeneous differential equation, first step is to write auxiliary equation. How to write auxiliary equation? Replace d by m in f of d. That means you will get f of m equal to 0. Replace d by m in f of d, then equate that to 0. You get f of m equal to 0. This is called auxiliary equation. This is called auxiliary equation. Now solve this auxiliary equation. You get, if it is a polynomial if it is a polynomial of degree n, then you get n roots, n roots, m1, m2, m3 up to mn. You get n roots. If you get second degree polynomial, you get 2 roots, third degree polynomial 3 roots. Similar to that, you get n roots generally. I am explaining general case. Here to write the solution, there are 3 possible cases. Case 1. Case 1. Roots are real and distinct. Real and distinct. See, if you look into these roots, see what are the various possibilities. One thing is, it may be a real number or it may be a complex number. ಇವೆರಡು ಬಿಟ್ಟು ಇನ್ಯಾವುದೋ ಪಾಸಿಬಿಲಿಟಿ ಇಲ್ಲ. ಒಂದು ರಿಯಲ್ ನಂಬರ್ ಆಗಿರ್ಬೇಕು ಆ ರೂಟು, ಇಲ್ಲ ಕಾಂಪ್ಲೆಕ್ಸ್ ನಂಬರ್ ಆಗಿರಬೇಕು. ಇವೆರಡು ಬಿಟ್ಟು ಇನ್ಯಾವುದೇ ರೀತಿ ಪಾಸಿಬಿಲಿಟಿ ಇಲ್ಲ. ಇದು ಫಸ್ಟ್ ಒನ್. ಸೆಕೆಂಡ್ ಒನ್, ಸಮ್ ಆಫ್ ದೆಮ್ ಮೇ ಬಿ ಈಕ್ವಲ್. ಸಮ್ ಆಫ್ ದೆಮ್ ಆಗ್ಬೋದು, ಕೆಲವು ಸಲ ಎಲ್ಲ ಈಕ್ವಲ್ ಆಗ್ಬೋದು, ನೋ ಪ್ರಾಬ್ಲಮ್. ಸಮ್ ಆಫ್ ದೆಮ್ ಮೇ ಬಿ ಈಕ್ವಲ್ ಆರ್ all of them may be distinct. All of them may be distinct. So these are the only possibilities. Either the roots are real numbers or distinct numbers. One condition. Second is, some of them may be equal, all of them may be equal, or all of them may be distinct, or some of them may be distinct. So either equality or distinct, that condition holds. So based on these, we will classify we get 3 cases here. Roots are real numbers and they are distinct. In that case, the solution will be y equal to constant 1, C1, constant 1 into e power root 1 x plus constant 2 e power root 2 x plus constant 3 e power root 3 x. This should be continued till the last root, constant n e power mn x. Case 2. Case 2. ಈ ರಿಯಲ್ ನಂಬರ್ಸ್ ಒಳಗಡೆ ಡಿಸ್ಟಿಂಕ್ಟ್ ನೋಡಿದ್ವಿ ನಾವೀಗ. What happens if they are distinct? Now let us look into this one. What happens if they are equal? Roots are real and some of them may be equal. Some of them are equal. To understand this better, assume first 3 roots are equal. So y equal to say m1, m2 and m3 are equal, and remaining roots are all distinct. m4, m5, these are distinct. Distinct ಇದ್ದಾಗ ಯಾವ ರೀತಿ ಬರೀಬೇಕು ಅಂತ ಗೊತ್ತಾಗಿದೆ. Now I have to check. I have to write how the solution will be if the roots are equal. Y equal to constant 1 C1 e power m1x plus m2 is a repetition of m1. m2 is a repetition of m1. I have to denote that repetition. Repetition ಆಗಿದೆ ಅಂತ ಹೇಳಬೇಕಲ್ಲ. ಸೊ ಮಲ್ಟಿಪ್ಲೈ ಆ್ಯಸ್ ಯೂಶುವಲ್ ಇದನ್ನು ಹಾಗೆ ಬರೀಬೇಕು. C2 e power, whether you write m2x or m1x, that is not a matter because they are equal. ನೀವು m1 ಆದರೂ ಬರ್ಕೋಬೋದು, ಇಲ್ಲಿ m2 ಆದರೂ ಬರ್ಕೋಬೋದು. To denote that repetition, I have to multiply this term by x. Actually, if you write x, that denotes first repetition, x power 1 ತರ. Plus m3 is a second repetition of m1. m3 is a second repetition of m1. So C3 e power m3x, whether you write m3 or m1, that's not a matter because they are equal, into x square. Plus, suppose in case m4 is a repetition of m1, then it will be third repetition of m1. ಅವಾಗ ಏನು ಮಾಡಬೇಕಿತ್ತು? as usual, fourth constant into e power m4x into x ಕ್ಯೂಬ್ ಥರ್ಡ್ ರಿಪಿಟೇಷನ್ ಅಂತ ಮೆನ್ಷನ್ ಮಾಡೋದಕ್ಕೆ. ಬಟ್ ಹಿಯರ್ ಇಟ್ ಈಸ್ ಡಿಸ್ಟಿಂಕ್ಟ್, ಸೊ ಇಟ್ ಈಸ್ ನಾಟ್ ಎ ರಿಪಿಟೇಷನ್. ಸೊ ಐ ಹ್ಯಾವ್ ಟು ರೈಟ್ ಫೋರ್ತ್ ಕಾನ್ಸ್ಟೆಂಟ್ e power m4x plus and so on, nth constant e power mnx. So that is about real and equal case. Next ಅದೇ ರೀತಿ ಕಾಂಪ್ಲೆಕ್ಸ್ ಮತ್ತು ಈಕ್ವಲ್, ಕಾಂಪ್ಲೆಕ್ಸ್ ಆ್ಯಂಡ್ ಡಿಸ್ಟಿಂಕ್ಟ್ ಎರಡು ಕೇಸಸ್ ಬರುತ್ತಲ್ಲ. ಸೊ ವಿಲ್ ಕಂಬೈನ್ ದ್ಯಾಟ್ ಇನ್ ಒನ್ ಕೇಸ್ ಓನ್ಲಿ. ಸೊ ಆ್ಯಸ್ ಯೂಶ್ವಲ್ ಈಕ್ವಾಲಿಟಿ ಬಂತಂತಂದರೆ ಈ ರೀತಿ ಎಕ್ಸ್ ಮಲ್ಟಿಪ್ಲೈ ಮಾಡೋದಷ್ಟೇ, ಅದಕ್ಕೆ ಮತ್ತೆ 4ನೇ ಕೇಸ್ ಬರೆಯೋ ಅಗತ್ಯ ಇಲ್ಲ. ಸೊ ಕೇಸ್ 3 ರೂಟ್ಸ್ ಆರ್ ಕಾಂಪ್ಲೆಕ್ಸ್. ಇಲ್ಲಿ ನಾನು ಮತ್ತೆ ಡಿಸ್ಟಿಂಕ್ಟ್ ಈಕ್ವಲ್ ಬರೆಯಲ್ಲ, ಬಿಕಾಸ್ ಇಫ್ ದೇ ಆರ್ ಡಿಸ್ಟಿಂಕ್ಟ್ ಯು ನೋ ಹೌ ಟು ರೈಟ್, ಇಫ್ ದೇ ಆರ್ ಈಕ್ವಲ್ ಯು ನೋ ಹೌ ಟು ರೈಟ್, then no need to separate that equal and distinct case, just roots are complex. So complex ಅಂತಂದರೆ ಯಾವ ರೀತಿ ಇರುತ್ತೆ, ಸಪೋಸ್ ಈಗ m1 ಕಾಂಪ್ಲೆಕ್ಸ್ ರೂಟ್ ಅಂತ ಅಂದ್ಕೊಳ್ಳಿ. ಸೊ ಆಲ್ಫಾ ಇಸ್ ಎ ಕಾಂಪ್ಲೆಕ್ಸ್ ರೂಟ್, ಸೇ ಇಟ್ ವಿಲ್ ಬಿ ಆಫ್ ದ ಫಾರ್ಮ್ a plus or I mean a plus bi, okay, a plus ib. So alpha, if it is a complex root, it will be of the form a plus ib. The thing is, when a plus ib is a root of some polynomial, a minus ib is also root of that polynomial. So your complex root will be of the form a plus or minus ib, and this counts two roots. This counts two roots. So this will be both m1 and m2, and then m3, m4 and so on. So alpha plus or minus I beta ಅಂತಂದರೆ alpha plus I beta ಒಂದು ರೂಟು, alpha minus I beta ಇನ್ನೊಂದು ರೂಟ್. ಅಲ್ಲಿಗೆ ಎರಡು ರೂಟ್ ಕೌಂಟ್ ಆಯಿತು, m1 m2 ಆಗೋಯ್ತು. ಅಲ್ಲಿಗೆ m3 m4 m5 ರಿಮೈನಿಂಗ್. These are real numbers. And in a worst case you may have again one more complex root, c plus or minus id. Suppose you have one more complex root, c plus or minus id, then this counts again two roots, that will be m3 m4 and so on, the remaining. So in this case y will be e power the real part. First ಇದಕ್ಕೆ ಮಾತ್ರ ಬರೀತಾ ಇದ್ದೀನಿ ನಾನೀಗ. e power real part, e power ax into cos imaginary part bx plus, okay, ಇಲ್ಲಿ ನೀನು ಕಾನ್ಸ್ಟೆಂಟ್ ಬರೀಬೇಕು. ಫಸ್ಟ್ ಕಾನ್ಸ್ಟೆಂಟ್ cos bx plus second constant sin bx plus c plus or minus id, you have e power real part cx times third constant cos dx plus fourth constant sin dx plus and so on. In case you have, say you had a plus or minus b here again, suppose ನಿಮಗೆ ರಿಪಿಟೇಷನ್ ಬಂದಿತ್ತು ಅಂತಂದರೆ, that in that case as usual you have to write this again, e plus ax into c3 cos bx plus c4 sin bx into x ಮಾಡಬೇಕಿತ್ತು ಅಷ್ಟೇ. So only that's the difference. Suppose, okay, I'll write it again, ಸುಮ್ಮನೆ ಕನ್ಫ್ಯೂಷನ್ ಬೇಡ. Suppose this is c plus id, no problem. Suppose you have this case, alpha equal to a plus or minus ib and beta is also a plus or minus ib. In that case y will be, first ಈ ರೂಟ್ ಬರೀಬೇಕು, e power ax into c1 cos bx plus c2 sin bx plus, so alpha plus or minus I beta ಬರ್ದಾಯ್ತು. ನೆಕ್ಸ್ಟ್ ದಿಸ್ ಈಸ್ ದ ರಿಪಿಟೇಷನ್. ಸೊ ರಿಪಿಟೇಷನ್ ಮೆನ್ಷನ್ ಮಾಡೋಕ್ಕೆ x ಇಂಟು e ಪವರ್ again ax times c3 cos bx plus C4 sin bx. So this is the way of writing the solution in the case of homogeneous PDE. So with this basic, in the next video we shall discuss problems on solution of homogeneous PDE.